Welcome to my channel. In this video, we are going to discuss about the multiple choice question and answer part 10. So from the third unit. So already we discussed that is 2 video. Okay, so for the third unit, this is the third video for the third unit. So in this, we are going to discuss about the causality and stability of the system and related problems. So what is mean by the system is to be causal. Okay. So the system, this LTI system, you know, the LTI system, it satisfies causality as well as the stability. Okay. So that is what is causality means. The system is said to be causal. Okay. Whenever the impulse response is 0 for negative values of time. So we can verify the LTI system is causal or not using the input. We can say if the output of the system does not depends upon the future input means it is said to be the causal. Okay. So that is one of the definition we discussed in the first unit. So here in terms of impulse response, okay, in terms of impulse response H of t, so we can define the causality, the system to be causal or not. So what is the thing means? If the impulse response is 0 for negative value of time, okay, means that system is said to be the causal system. So the condition is that the h of tau is equal to 0 for tau less than 0 or h of t is equal to 0 for t less than 0. That means the negative value of time, the impulse response value is 0 for one system means that system is called as a causal system. Okay, if impulse response is available, that is impulse responses available for the negative time means that system is not a causal, it's a non-causal system. Okay, so for one causal system, the output y of t it can be written as, so already you know, using the convolution integral formula, the output is nothing but the convolution between the input and impulse response. Okay, integration minus infinity to infinity that value. So for causal system, so that output equation is reduced to integration 0 to infinity. Okay, since you know the h of tau value is 0 for tau less than 0. Okay, then since the impulse response is available only for the positive duration. So that's why the integration we can limit it to 0 to infinity x of tau h of t minus tau into d tau. Okay, so this is the causality. And similarly stability. So the system is said to be BIBO stable. Okay, BIBO means already you know, bounded input, bounded output, stable system. So in terms of input, we can define the system to be stable. It has to produce the bounded output for the bounded input. Okay, that is bounded means finite. So for a finite input, the system produces finite output means we can say that the system is said to be stable. Okay, but in terms of impulse response, so how can you define the impulse that is the system is said to be stable or not means the definition is that its impulse response is absolutely integrable. Okay, if the impulse response of the system is absolutely integrable means that system is said to be the stable system. What is absolutely integrable? That is if you are integrating the impulse response value over the limit minus infinity to infinity, if you are obtaining that answer is less than infinity means we can say that that system is a stable system. Okay, so these are all the condition for causality and stability. So already we discussed this causality, stability and related problem. Okay, so many Anna University problem we solved. Okay, I posted the video in the third unit. So if you want to learn more about that video means, so I will give link in the description box and I code also, you can refer it. Okay, so now we will see the multiple choice question and answer from this causality and stability of the system. So first question you see, the causal continuous time system with impulse response should satisfy dash equation. So the first choice you see, h of t equal to 0 for t less than 0. H of t equal to 0 for t greater than 0. H of t not equal to 0 for t less than 0 and another one. So the first choice is a correct answer. So already we defined, you know, the system is said to be causal if the h of t equal to 0 for t less than 0 or h of tau. Instead of the variable t, we may use the dummy variable tau also. Okay, this is the condition. So the first is the answer. H of t equal to 0 for t less than 0. This is the condition for one causal system in terms of impulse response. Okay. Then the next one, the causal systems are dash anticipative, non-anticipative, for certain cases anticipative, for certain cases anticipative and non-anticipative. So the answer is non-anticipative. So what is the meaning? Means the causal systems are non-anticipative. That means they cannot generate an output before the input is applied. Okay. So once we are applying the input only, that system produces the output. So which indicates the impulse response is 0 for negative time. Okay. So already know the definition. The impulse response of the system is 0 for negative value of time. Means that is said to be the causal system. Okay. So whenever we are applying the input, at the time only the system generates the output. So the causal systems are non-anticipative. Okay. Then the third question, using that is one impulse response of one system is given, we can verify this system is causal or not. Okay. So this problem may come for 2 mark question also. Okay. So this is a very important question. Check whether the given system is causal or not, stable or not. These are all the important 2 mark problems. Okay. Check whether the following system with the impulse response given is causal. Okay. What is the given equation? H of t equal to e power minus a t u of t. This is the impulse response of the given system. So we can say that we can verify the given system impulse response is causal or not. So already you know the definition. The impulse response of the system, it should satisfy the condition. What is the condition? The impulse response is equal to 0 for negative value of time. Okay, t less than 0 means if one system satisfies this condition means that system is called as a causal system. So here you see h of t equal to e power minus a t u of t. So what is the meaning? This e power minus a t multiplied with u of t. So already you know any function multiplied with u of t means this function is only available for t greater than 0. For t less than 0, this h of t value is 0. Okay, so that's why the given impulse responses, the given system is a causal system. So you see the given impulse response h of t equal to e power minus a t u of t. This is 0 for t less than 0. For t greater than 0, this u of t indicates for t greater than 0 only this impulse response is available. So the system is said to be causal. Okay, similarly the next problem you see, check whether the following system with impulse response given is causal or not. Okay, h of t equal to e power minus a modulus t. Okay, so e power minus a modulus t. So already you know that is e power minus a modulus t we solved in Laplace transform and Fourier transform problem. Okay, so e power minus a modulus t. Modulus t means this t, it will take a positive value as well as negative value. So if t is positive means it behaves like a different signal. If t is negative means this signal it behaves like a different one. Okay, so how can you expand this e power minus a modulus t? So you first consider this t is positive. So positive means, so we can write it as e power minus a t into, this is for positive time. If in order to indicate the positive time, we can multiply that one with u of t. Okay, similarly plus we can assume this t as a negative minus t. So e power minus a minus t. So it can be written as e power a t. Okay, exponentially rising signal. This e power minus a modulus t, it will behave as an exponentially rising signal for the negative time. So in order to indicate the negative time, we can put, we can multiply u of minus t. So this is the expanded version of this h of t. Okay, so according to this, we can say that, so the first part you see, the h of t, it is the addition of 2 parts. In the first part, the e power minus a t multiplied with u of t. So this is available only for positive duration of time. Okay, but here you see e power a t multiplied with u of minus t. What is u of minus t? It's a negative, that is minus infinity to 0. The u of minus t is having the amplitude 1 for minus infinity to 0. So that's why this second part is applicable for the negative time interval. So that's why this impulse response is available in both positive time as well as negative time. So that's why the system is said to be non-causal. Okay, or otherwise it can be that is said as this impulse response depends upon the present and future input. So that's why the system is said to be the non-causal. Okay, if the impulse response is available only for the positive time means the system is said to be causal. But here e power minus a modulus t. So modulus t indicates positive time as well as negative time interval. So that's why this is the non-causal. Okay, then the next one, check whether the impulse response is causal. H of t equal to e power minus at u of t minus 1. Okay, so what is u of t minus 1? The u of t minus 1 means already you know u of t means this is the u of t. Okay, for the time 0 to infinity the amplitude is 1 means it is called as a u of t. Then what is u of t minus 1? 1 second right side shifted value. Okay, at a time t equal to 1 to infinity the amplitude is 1 means this is called as a u of t minus 1. So this u of t minus 1 multiplied with one exponential signal means, so this entire part is available only for the time t greater than 1. Okay, so that e power minus at u of t minus 1 it is available. Okay, the signal is available from the time t equal to 1 to infinity. So for the negative time this h of t is not at all available. So the given system is said to be causal. Okay, this equation it satisfies the condition h of t equal to 0 for t less than 0. So that's why this system is causal. Then the next one, h of t equal to e power at u of minus t minus 1. So what does u of minus t minus 1 means? So this u of minus t minus 1 it is available for the negative time interval. Okay, so the given impulse response is not equal to 0 for the t less than 0 condition. So that's why it does not satisfy this condition. So this system is said to be non-causal. Okay, so these are all the some of the problems. So similarly, you see one more problem, h of t equal to e power at u of t plus 1. What is u of t plus 1? So we discussed one problem. This is u of t minus 1. U of t minus 1 means that signal is available from 1 to infinity. But u of t plus 1 means it's a 1 second advanced unit step signal. That is u of t plus 1 means that u of t plus 1 is having the amplitude 1 for the time minus 1 to infinity. So here for the negative time, okay, so for the negative time this h of t is available. Okay, so it does not satisfy the condition h of t equal to 0 for t less than 0. Okay, it does not satisfy this condition since the h of t is available during the interval minus 1 to 0. So that's why this system it is said to be the non-causal system. Okay, so if only the given h of t is available only for the positive duration from 0 to infinity means the system is said to be causal. Okay, so h of t is available for the negative time duration means the system is said to be non-causal. Okay, these are all the things about the causal system. Okay, so next one, the stability. So using stability, we can solve some problems. The first one, the LTI CT system is said to be stable if its impulse response is dash. Okay, so already we discussed, stability. So what is stability? If the system, in terms of impulse response, the system is stable if the impulse response is absolutely integrable. Okay, if you are integrating the impulse response, we will get the answer is less than infinity means that system we are calling it as a stable system. Okay, so that's why you see the LTI CT system. LTI means linear time invariant. CT means continuous time system. This is said to be stable if its impulse response is absolutely integrable or absolutely summable. Absolutely integrable. So this absolutely summable is for LTI DT system. DT system means discrete time system. Okay, so you just note down. So what is the system they are asking? If LTI CT system means the condition is that absolutely integrable. If it is a LTI DT, 5th unit, okay, the 5th unit system, linear time invariant discrete time system means for the system to be stable, the condition is that absolutely summable. Okay, then the next one, yeah, the LTI CT system is said to be stable if its impulse response satisfy the condition. Okay, so that condition, okay, that is we discuss, integration minus infinity to infinity h of tau d tau, it should be less than infinity, or h of t dt, it should be less than infinity. Okay, both are same only. So here 4 condition given. First one, h of t equal to 0 for t less than 0. This is the condition for causality. H of t equal to 0 for t greater than 0. No. Okay. Integration minus infinity to infinity modulus of h of tau d tau. It should be less than infinity. Okay. This is the correct answer. So this is the condition to be satisfied by the system. It to be stable. Okay. Then the next question. Step response. Okay. The step response is defined as response of the system when dash. Okay, so we discussed one impulse response. What is mean by impulse response? This response means output. Okay, simply output. The output produced by the system for the input is impulse signal. Similarly, step response means, so for one system, if you are applying, the input is unit step signal. Okay, what is mean by unit step signal? U of t. So for one system, if we are applying the input as u of t means we will get one output. So that output we are calling it as a step response. Okay. So step response is defined as response of the system when the input applied is unit impulse signal. No. Okay. If you are applying unit impulse signal means at the time we will get the impulse response. Okay. The input is unit step signal. Yes, correct. The input is ramp signal. No. Okay. So B is the answer. So step response means response of the system for the given input is a unit step signal. Okay. Then the next one is the system h of t equal to exponential of minus t u of t is a stable or not. Okay. We can verify. So already the system to be stable means it should satisfy the condition. That is, we have to integrate the h of t over the interval minus infinity to infinity, and this answer it should be finite, that is less than infinity. So if you are integrating this, we will get the finite answer means the system is said to be stable. So here the h of t value is given. So we have to integrate and we have to find out the answer. If that answer is finite means stable. The answer is infinite means unstable. Okay, so we can verify it. So you just integrate e power minus t u of t. So integration of minus infinity to infinity e power minus t u of t dt. So the u of t, if in integration u of t is available means the integration limit we have to restrict to 0 to infinity. So integration 0 to infinity e power minus t dt. Okay. So if you are integrating this, we will get e power minus t by minus 1 with the limit 0 to infinity. So we will get the answer, finite answer. So that's why the system is said to be stable. Okay, so in the next problem, I solved. Okay, similar to this, the problem that is the solution solved. So you see, is the system h of t equal to e power minus 3t u of t minus 2 is stable or not. Okay. So if the system is said to be stable, the impulse response is absolutely integrable. That is, this is the condition. So in this condition, we have to substitute the value of h of t. So what is the h of t? E power minus 3t u of t minus 2. So what is the meaning of u of t minus 2 multiplied with one function? The u of t minus 2 means this signal is available only for the time from t equal to 2 to infinity. This is the u of t minus 2. Okay, that's why in the integration limit, we have to restrict to 2 to infinity. The minus infinity to infinity is reduced to 2 to infinity since e power minus 3t multiplied with u of t minus 2. Okay, so if you are integrating this part, e power minus 3t by minus 3 with the limit 2 to infinity. If you are substituting the upper limit, okay, infinity means e power minus infinity is 0. Then minus of, if you are substituting the lower limit, so e power minus 3 into 2, so e power minus 6 by minus 3. So this minus minus cancelled, then e power minus 6 by 3. So if you are calculating the answer for this e power minus 6 by 3 means we will get 8.26 into 10 to the power minus 4. So this answer is finite or not? Yes, finite. Okay. So it should be less than infinity. So the given system is stable system. Okay. So similar to this way, we have to solve this e power minus t u of t problem. Okay. So already I'm having this problem. I will check. You see, this is the problem e power minus t u of t. Okay. This question, the previous question, 11th question. Check whether h of t equal to e power minus t u of t is stable. Okay, so you see the given system. This is for causal. Okay, so if it is for a stable system, we have to use, so similar to this formula, integration 0 to infinity this e power minus t dt. So if you are integrating this, we will get e power minus t by minus 1. Okay, with the limit 0 to infinity. So if you are substituting the upper limit 0, then minus of, if you are substituting the lower limit 0 means 1. So 1 by minus 1. So minus minus cancelled, we will get the answer is 1. So it's a finite. So the system is said to be stable. Okay, and the system is causal or not? Causal. Since the e power minus at is multiplied with u of t. So the impulse response is only available for the positive time. So this system is also a causal. Okay, causal. And you can see the one more problem. Check whether the causal system with a transfer function h of s equal to 1 divided by s plus 1 is stable. Okay, it's a stable or not. This is the question. So instead of impulse response, here the transfer function is given. What is the relation between impulse response and a transfer function? If you are taking Laplace transform, okay, Laplace transform for this h of t, we will get the transfer function h of s. Okay, in this problem, h of s is given. We have to check that system is stable or not. Okay, so using this h of s, first we have to find out the h of t. So from h of s, how can you obtain h of t? We have to take inverse Laplace transform. Okay, so given that h of s equal to 1 by s plus 1. So if you are taking inverse Laplace transform, the inverse Laplace transform of h of s equal to small h of t. So what is the inverse Laplace transform of the structure 1 by s plus a e power minus at u of t? So in the place of a, which one is there? 1 is there. So e power minus t u of t. Okay, so taking inverse Laplace transform, h of t equal to e power minus t u of t. Okay, then so for this impulse response, we have to substitute this impulse response in this above equation. We can find it's absolutely integrable or not. Okay, so if you are integrating, so you see integral minus infinity to infinity h of tau d tau. So e power minus tau into u of tau. So you know u of t it will come means the integration limit we have to restrict to 0 to infinity. So after integration we will get the answer is 1. So it's a less than infinity. So the given system is stable system. Okay, the given system is a stable. So 1 by s plus 1 h of s equal to 1 by s plus 1 is a stable system. The impulse response of the system is e power minus t u of t. Okay, this is the one. And the next one, the impulse response of the system is given as h of t equal to del of t plus e power minus 3t u of t plus 2 into e power minus t u of t. Determine the transfer function of the system. Okay, so here what's the given data? Impulse response is given. The question is that find the transfer function. What is mean by transfer function? H of s. What is the relation between h of s and h of t? If we are taking Laplace transform for h of t, we will get transfer function h of s. Okay, so you just take a Laplace transform for this impulse response. So if you are taking Laplace transform for each part, so first you see what is the Laplace transform of del of t 1. Okay, so already we know the standard answers. Okay, so in the previous second unit, we solved all problem. What is the Laplace transform of del of t 1? Okay, what is the Laplace transform of e power minus 3t u of t 1 by s plus 3? Okay, it's in the structure 1 by s plus a. What is the Laplace transform of e power minus t u of t? Before that, the constant 2 is there. So you write 2 as it is. The Laplace transform of e power minus t u of t is 1 by s plus 1. Okay, so h of s equal to 1 plus 1 by s plus 3 plus 2 by s plus 1. Okay, this is the transfer function. So here the answer is given in a reduced structure. Okay, so that's why you may take LCM for these three parts. Okay, so you take LCM s plus 3, s plus 1. Here s plus 3, s plus 1 plus s plus 1 plus 2 into s plus 3. Okay, so you multiply these part. So in the denominator we will get s squared plus 4s plus 3. So similarly, you just simplify the above thing. Okay, we will get s squared plus 7s plus 10 divided by this. Okay, so you verify which one is correct. The A is the correct. S squared plus 7s plus 10 by s squared plus 4s plus 3. Okay, so this is the one way of question. Okay, impulse response given, you just find transfer function. Or inversely, the transfer function given, you may find the impulse response. So it is also one of the 2 mark question. Okay, so this is the answer. And next one, the impulse response of the system is given as h of t equal to e power minus t u of t. Determine the transfer function. Okay, so the reverse question, impulse response is given. The question is that we have to find the transfer function. So what is the relation? You just take a Laplace transform for the h of t. So this is the given impulse response. So if you are taking Laplace transform, the Laplace transform of small h of t, it is indicated as capital H of s. So capital H of s equal to what is the Laplace transform of e power minus t u of t? According to the standard Laplace transform pair, e power minus a t u of t is having the Laplace transform 1 by s plus a. So that's why 1 by s plus, what is the value of a here? 1. So 1 by s plus 1, this is the answer. So whereas this is the first answer, 1 by s plus 1 is the transfer function of this impulse response. Okay, this is the one type of question. And here the h of s is given. We have to find the impulse response. So the system function h of s equal to 4 minus 3 divided by s plus 2. Find the impulse response h of t. Okay, so here we have to take in order to obtain the time domain impulse response from the Laplace transformed domain, you just take inverse Laplace transform. Okay, so you see, you just take inverse Laplace transform for the above equation. So what is the inverse Laplace transform of simply the constant 4? It's a del of t. Okay, so 4 into del of t. Since you know the Laplace transform of del of t is 1. Okay, so one constant is available means the inverse Laplace transform is 4 into that del of t. Then minus 3, you write as it is. So 1 divided by s plus 2. The inverse Laplace transform of 1 by s plus 2 is e power minus 2t u of t. Okay, so this is the impulse response of the given system. So where is the answer? You can see the first one, no, okay, 4 into del of t is not available. In second also del of t not available. So in the third one, 4 into del of t minus 3 e power minus 2t u of t. So this is the correct answer. Okay, so you can see here e power plus 2t is given. Okay, this is not a correct, this is the correct one. Then the next problem is the system e power minus 2t u of t minus 1 is stable or not. First, the system is causal or not? Causal. Okay, since the system is multiplied with u of t minus 1. That's why this impulse response is available only from the time t equal to 1 to infinity. So this is the causal. So we can verify this one is a stable or not. Okay, so according to this condition, So the impulse response, if it is absolutely integrable means we can say that is a causal. So we have to verify it. So integration minus infinity to infinity h of t dt. So e power minus 2t, we have to substitute the value of h of t here. So in the h of t, u of t minus 1 is available. So what is the meaning of u of t minus 1? We have to restrict this integration limit is from 1 to infinity. Since u of t minus 1 is available for the time only 1 to infinity. So integration 1 to infinity e power minus 2t dt. So if you are integrating e power minus 2t by minus 2 with the limit 1 to infinity. So if you are substituting the upper limit e power minus infinity 0. Minus of if you are substituting the lower limit e power minus 2 into 1 divided by minus 2. So minus minus cancel, we will get e power minus 2 by 2. So the answer for e power minus 2 by 2 is, it should be a one finite answer. So the system, the given system is stable. Okay, the system is a stable system. One more question, is the system h of t equal to t into e power minus t u of t is a stable or not? Okay, same way we have to verify it. Instead of h of t, we have to substitute the value t into e power minus t u of t. And you know u of t means the integration limit is reduced to 0 to infinity. Then how can you integrate this t into e power minus t? Using the integration UDV method. Okay, so integral UDV equal to UV minus integral VDU. So if you are solving this integration, we will get the answer. It is finite, 1. Okay, so that's why the system is said to be stable. Okay, since the integration of h of t dt, it is 1. Okay, it's a finite answer. So this system t into e power minus t u of t is also a stable system only. Okay, then the next one is the system h of t equal to 1 by rc e power minus t by rc u of t is a stable. Stable or not? Okay, same way. 1 by rc e power minus t by rc, you just substitute the h of t value. In this 1 by rc is a constant, you take it outside. Then the u of t, by the use of u of t, the integration limit, we have to restrict to 0 to infinity. Then you integrate this part. So e power minus t by rc by minus 1 by rc. So here 1 by rc cancelled. Then if you are substituting the upper limit 0, minus if you are substituting the lower limit 1 by minus 1. So the answer is 1. Okay, so it's a stable only. Okay, so the system is stable, yes. These are all some of the questions about the stable system. Okay, we solved 6 to 7 problems in order to check the stability and causality. So the next question, what is the step response if the impulse response of the system is h of t? Okay, so we can derive, there is a formula is there in order to derive the step response from impulse response. Okay, if one system impulse response, you know, h of t, you know, means we can derive the step response using the formula. So which formula means S of t equal to integration minus infinity to t h of tau d tau. Okay, this is the correct formula. So the remaining and all, some integration limit will be wrong. Okay, so this is the correct choice. The if impulse response of the system, you know, means if we want to find the step response, the formula is that the step response S of t equal to integration minus infinity to t, we have to integrate h of t. Okay, this is the correct thing. So you can remember it. This is the relation between step response and impulse response. Then the next one, what is mean by natural response? Okay, so natural response means the output produced by the system only due to initial conditions. Okay, that means this LTI continuous time system, it consisting of some inductors and capacitors, that is energy storage elements. Okay, will be there. So if you are giving some inputs, okay, means that inductor and you know that is the resistor only instantly responding device, and capacitor and inductors are it's a transient device. Okay, transient means it slowly the value increases or decreases. So if in one system, after removing the input also, if you are measuring the output, means in that LTI DT system, CT system, we will get some minimum current is flowing if the system consisting of inductor and capacitor. So that data we are calling it as a initial conditions. Okay. So that response is called as natural response. So what does mean by natural response? The output produced by the system only due to initial condition. Okay. Then the second one, output produced by the system only due to input. This is not a natural response. That is a forced response. Okay. Then both initial and input. This is the total response. Okay. These are the three things. So natural response means the output produced by the system only due to initial condition. Okay. So previous stored data, due to previous stored data, we will get some output, that is said to be natural response. Okay. Then next question, what does mean by forced response? So the question itself answer is there, forced. So forced means in one system, if you are applying the input x of t means we will get the output. Okay. So this output y due to the application of input, that output is called as forced response. So output produced by the system only due to initial condition. No, this is the natural response. Output produced by the system only due to input. Yes. Okay. Due to the external input, we are getting some output means that is called as a forced response. Okay. Then what is mean by complete response? So if we want to calculate the complete output of the system means the complete output is nothing but it's an addition of, it's a sum of natural response and forced response. So what is the meaning? The complete output of the system is nothing but that is due to input, we will get some output plus due to the previous initial condition, we will get some output. So addition of natural and forced response is said to be the complete response. Okay, so you see the same four choice, output produced due to only initial condition, output produced only due to input. The third one, output produced by the system due to initial condition as well as input. So the C is the complete response of the system. Okay, then which one is called as zero input response? So in this forced response, natural response and complete response, which one is called as zero input response? Okay, so zero input means whenever we are applying no input, we will get some output, that output is called as zero input. So which one? Natural response. So the other name of natural response is called as zero input response. Okay, the natural response is nothing but, output due to the initial conditions, not the input. Okay, so during the input is zero, we will get some output. That output is called as a natural response. Then the next one, the LTI CT system is represented by difference equation, differential equation, both A and B. The LTI continuous time systems is always represented by differential equation. Okay, that is d squared y of t divided by dt squared plus 2 into d squared y divided by dt. Okay, plus x of t equal to some value. It is called as a differential equation. So the LTI CT systems are represented by differential equation. So what is this difference equation means? The difference equation is used to represent LTI DT system, discrete time system. So the fifth unit system is represented by difference equation. That is y of n minus 2 plus 2 into y of n minus 1 equal to x of n. That is the difference equation. So continuous time systems is described by differential equation. Discrete time system is represented by difference equation. Okay, that is the thing. Then what are all the blocks used in the realization of LTI CT system? Okay, so we discussed the last topic, in the third unit, the block diagram representation or realization of system. That is, in order to obtain the block diagram representation of LTI CT system, what are all the elements we needed? Adder, scalar multiplier, integrator, all of the above. Okay, all these three value we needed: adder, scalar multiplier, integrator. Okay. Then why integrator block is used instead of differentiator in the realization of LTI CT system. Okay, so in that part, that is in the block diagram representation, I discussed this question. Okay, that is there is a differentiator block is also there, but we are not at all using the differentiator block in the realization of LTI CT system, even though the LTA system is mentioned by differential equation. We are not at all using the differentiator block. Okay, so that value we can obtain using the integrator block only. Okay, why? What is the reason? Means the integrator reduces the noise. Integrator amplifies the noise. Cost is high, large size. Integrator reduces the noise. That is the reason we are using integrator instead of differentiator. Differentiator, it will amplify the noise. Integrator, it will reduce the noise. So that's why in the realization of system, we are using the integrator block instead of differentiator block. Okay, so this is the reason. Then what is the advantage of direct form 2 realization when compared to direct form 1? Okay, so in the realization, there are 4 types, direct form 1, 2, cascade and parallel. So that is in that thing, the direct form 2 realization is advantage when compared to direct form 1. Okay, so what is the reason? Means in direct form 2, in center, we can use the integrator. So these integrators are shared by the 2 sides. Okay, that's why the number of integrator, the 1 by S block used is reduced to half. That is the advantage of direct form 2 realization. So number of integrator used reduces. Number of adders reduced by half. Number of scalar multiplier reduced by half. All of the above. No, the first one is the answer. Number of integrator used is reduced by half amount. There is no change in the number of adder, number of scale multiplier. Number of integrator. Since in the direct form 2 diagram, in center, we are using the integrator block. So this integrator block output we can share by the input side and output side. So this is the reason. Okay. Then the next question, a certain continuous time linear time invariant system is described by the differential equation is given. Determine the impulse response. Okay. One system equation is given. We can find the impulse response. So in order to, that is here, the differential equation you see, y of t is the output, x of t is the input of the system. So using this time domain equation, we have to find the impulse response. Okay. So in order to obtain the impulse response, so first we have to apply the Laplace transform for the differential equation. Okay. So what is the Laplace transform of dy of t divided by dt? So using the differentiation property of Laplace transform, so s into y of s plus 5 into what is the Laplace transform of y of t? Y of s equal to what is the Laplace transform of x of t? Capital X of s. Then in this part, we have to take y of s as a common. So s plus 5 equal to capital X of s. So from this, the ratio y of s by x of s, it is nothing but a transfer function h of s. So h of s equal to 1 by s plus 5. Okay. So from the given differential equation, first we have to find out the transfer function. Then, from the transfer function, we have to obtain the impulse response. Since, the impulse response and the transfer function is a transform pair. So for this 1 by s plus 5, we have to take inverse Laplace transform. So if you are taking inverse Laplace transform, the answer is the h of t equal to e power minus 5t u of t. So this is the impulse response of the system. So e power minus 5t u of t. So this A is the answer. Okay, so it is one of the questions. So this questions, so many questions we solved in the 3rd unit. Okay, so in a big question, 8-mark question problem. So now it's a multiple choice question pattern, so you may, you may get this like questions in a 2-mark problem also. Okay, so h of t equal to e power minus 5t, u of t is the answer. Then the next question, an LTI system is said to be causal if all poles of the system function lie on the left half of the ROC. It's a true or false? It's a true only. Okay, if That is we can say the causality in terms of input output, the another one in terms of impulse response, the third one is in terms of ROC, in terms of poles. Okay, what does it mean by pole? Pole means the roots of the denominator polynomial of the system function. System function means transfer function h of s. Okay, in terms of poles, if we want to find the system is said to be causal or not, means if all poles lie on the left half of the ROC. Okay, left side of the ROC means that system is said to be the causal. Okay, this is the left side. Okay, left side of the ROC, all poles are available means the system is said to be causal. Similarly, the LTI system is said to be stable if and only if the ROC of its system function includes real of s is equal to 0. That is j omega axis of the S-plane. Yes. Okay. Whenever the system is said to be stable if the ROC includes the j omega axis. Okay. This is the j omega axis. This is the real value. This is the imaginary value. Okay. So the ROC of the system includes real of s equal to 0, that is j omega axis of the S-plane, means the system is said to be stable. Then the system will be causal and stable. Okay, so if one system, it should be both causal and stable if and only if all the poles of h of s lie on the left side of j omega axis, that is left half of the S-plane. Okay, if all poles are lies in this left half of the S-plane, means the system is said to be causal and stable. It's a true only. Okay. According to the first condition, if all poles are left side of ROC, means it's a causal. For stable, it includes j omega axis. Okay. The ROC includes j omega axis, means we can say that as a stable. So the system to be both causal and stable, all poles of h of s lie in the left half of the j omega axis. That is left half of the S-plane, means we can say that the system is said to be causal and stable. So yes, true statement. Okay. So these are all the questions we discussed from the stability and causality of the LTI discrete time system. Okay. So in the next video, I will discuss about some more questions. So thanks for watching this video. And if you want to learn more about this causality, stability, and more problem means, I will give the link for those videos in the description box. You can verify it. Okay. So in signals and system playlist, so unit wise all topics, that is so many problems we solved. If you want to learn, go and learn. Okay. So thanks for watching my channel, and please subscribe my channel for more videos and share this video to your friends also. Thank you.